Hey everybody, it's Stove Talk with Matt. We usually get a bunch of stove experts here, people that know more than me about many types of stoves. But remember, my goal is always to help the novice or somebody that doesn't know anything about this and to bring them up to speed. So I know we don't get a lot of novices here, and YouTube's not showing my videos to too many people, but that is the goal of this channel. I apologize to the experts, but I want everybody should be able to have one of these stoves. And building a real full-size masonry heater that heats pretty much the whole small home is very simple if you adhere to certain principles. I'm going to show you how to build a full-size, simple masonry heater. This video will probably get pretty long, so let me just start with the summary, see if you want to continue. You basically just build a firebox made of fire brick, and you surround your firebox with a box of red brick. It's a box inside of a box with the pipe along the back at the bottom. It's a foolproof design. It almost can't go wrong. It works as well as almost any masonry heater. This is mine, and inside this red brick box is a firebox similar to what you just saw. You simply do a box inside of a box, vent it, and there you go, masonry heater. I stacked up some mini bricks to show you the absolute simplest design of the firebox. If you just wanted to do this, mine looks a little bit more complicated, but it really is not much different than this. Your base is just 2 bricks across. A US fire brick is 9 inches long. So the firebox is only 9 inches wide. That is plenty. A thin firebox and a tall firebox radiates heat, reflects heat back, and eats up more smoke than a big fat wide firebox. You simply do your base, which is in total it's 3.5 for your base, 3.5 long. And again, it's only 2 across in terms of US fire bricks. On top of your base, you simply build up, you go around and make a horseshoe of 3 levels. And then on the next level after that, you just start going halves until you get to your top and you make a little 4 brick ceiling. The idea is the pipe is behind the highest part. You want to hide the pipe. A principle making a simple masonry heater is burn the fire and hide the pipe. Make the smoke have to work hard and wrap around corners and go over the top and down to get to the pipe and get out. You don't want to give easy access to the pipe. The heat then stays inside the masonry heater. So this is the firebox with fire brick. And then you just put your red brick, your clay and shale brick around this. Simple. Matt, don't you need to put a rocket stove inside of a brick box? And you don't have to make no rocket stove. You don't have to get into all that. And what size should the port be? And what side should the riser be? You know, there's probably a little bit less smoke with the rocket stove. And the big advantage, this is basically smoke-free. You can see it there, a little bit of smoke here and there as it heats up. And as your brick box around it heats up, there's going to be even less smoke than that. And that's next to nothing. The big disadvantage, the advantage of this is simplicity. You can basically build a full-size masonry heater in a day if you really wanted to. The disadvantage is the amount of wood. A rocket stove, of course, or some sort of batch boxes, smaller pieces, and just this. You need to throw 3, 4, 5 pieces of oak. It'll go for an hour and a half, 2 hours. You only need to burn it twice a day to keep all those bricks warm. This is just super simple, but if you use this a lot in the winter, you see all the woods behind my house and dead trees all over. You need access to wood, but you don't need no rocket stove. No, you just put this sort of simple firebox inside your brick box. Here's a still image so we can talk about some of the particulars. The stove, again, is only 2 bricks wide, 9 inches plus 9 inches, 18. The firebox then is only 1 brick, 9 inches. That is plenty. You can put big pieces of oak in here, no problem. The bottom door, so the door to load the wood is, just 4 bricks high, 2.5 inches per brick. Remember, you would need another square for the red brick. You need to make that square through the red brick. Your door would go in the red brick. But then you need to leave this opening so you can load your wood through the red brick, then into the square of the fire brick. Then the bottom is the ash clean out door, or the which is 1 brick across, or air door. That's where the air comes in and then the grate. This is a 27-inch long firebox, so you don't have to be perfect with it. In this stove, you might be able to see it in later videos. I put a 4-inch grate up front, not just up front, but towards the front, and I put more like a 6 or 7-inch grate along the back. And maybe I'll talk about those particulars. If I had to do it, I wouldn't. I got too cute. There's no reason for that. You just do roughly in the middle 14 to 16-inch grate, and your first 5 or 6 inches or whatever is fire brick, or you do 2 fire bricks in the front, 2 fire bricks in the back, and then the middle is just a grate. I tried to see if I could get more flame to lap up along the back by putting that grate in the back and then in the front, and you don't need to do that. So air door in the again when you do your red brick box around this fire brick, you would need again same type of door in your red brick for the airflow and to get your shovel in for ash clean out. Your ash then falls through the grate. Grate stoves don't hold they burn much more intense where the air is coming up underneath the wood, and they burn more intense than a hearth stove where you just throw the wood right on top of the fire brick. You get more intense temperatures. You absolutely get less smoke. If smoke is an issue, make it a grate stove with the air coming in from underneath. And but you don't have coals. I mean, these stoves are not meant to just be burned all the time like an iron. Iron stove. You don't have coals in the morning. Everything burns up to a fine ash in just an hour and a half or so. That's normal for a grate stove. And then here you place the firebox we just saw. You build this, of course, around the firebox we just saw. And in my particular stove here, I only have 3.5 to 4 inches on the side. 3.5 inches. It's very tight. And when you get it right, it does draft really aggressively. But if you're building this as an amateur, you don't need to be too perfect. You can have each channel, the difference between the fire brick wall and your outside wall of brick, 4, 5 inches. You don't want it too big because things slow down when channels get too big. It's not, you still will draft okay, but I don't know. I only have 3.5 inches. I'll show you a picture of how tight mine is. It's a little, took a risk, but it works. But if you're building this as an amateur, look how tight mine is. There you go. The flame that my firebox is a little different. I closed it off at the top. It goes through an additional channel, and it kind of spits out that top of the firebox towards the camera, towards where you're viewing this, and then it wraps around the left and wraps around the right, and the pipe then has a hole at the bottom. I should show you that next. But I'm only 3.5 inches on the sides. You'd probably want more like 4 or 4.5 or 5. Don't need to be. It was also very difficult to build when pieces of stuff would go down there. It was hard to clean out that little space. I put a piece of metal across for something I was testing. You could see the flames then would wrap around through those holes to the left and to the right. If you were just building a brick box around this, you would need that piece of metal. If you ever burn metal like that that's galvanized, be very careful. It's very poisonous until it all burns off. You just leave it open. And those bricks sticking straight up, don't worry about that either. They're not necessary. I'll show you a picture a little later. Just keep it completely open up top. Here's how you would vent the exhaust. The chimney would be in the back of the stove. Here the hole points backwards. Just as an example, you have flexibility here, and I'll show you some more options, show you that later. Again, this is just my stove that I built, and this is my brick box. The doors I got from the Ukraine that were from the 1970s Soviet Union. And this is just what I did in terms of my brick box around a very similar firebox to what I just showed you in the test. My pipe just runs down the back, and I have a 6-inch hole at the bottom of the pipe where the gases wrap around the sides and go up the pipe and out. Because I use pavers, which are symmetrical, I've made this little alcove, which you wouldn't need to do for the pipe. Pavers are symmetrical. Red brick is not symmetrical. So back to the still image for the firebox. It's a little different from those little tiny red bricks that I stacked up because my test I built up the front a little bit more. You don't need to do that because remember your red brick is really going to be the front wall of the stove. You want the flames to kind of not lap up against the red brick in the front, but the radiant heat. You want your red brick in the front where your doors are to get warm. You just make, sometimes you make a little bit of a wall to protect you protect your door from any possible smoke. You make little shelves and things. So if there is any smoke, it has a hard time getting out your door when you open the door to add more wood. But you don't need to go back to those little mini red bricks. That's really all you need to do. You need ample room for the gases and smoke to escape around the sides, which is that tiered system allows, and it can escape out the top. Either way, it's going to be forced to wrap around to get out and into the pipe. I'm going to show you this video again on the other side of the video of my Firebox test. This is all you need, guys. The simple is all you need, because you're building, I think I mentioned building doors and stuff. You need to build the ash clean out door, the air door, into the red brick box, and your door to load the wood into the red brick box. The Firebox, all it needs to be is this. You just literally need something like this tiered to throw the wood in. Because your pipe's in the back, some gases will escape around the front, but everything kind of wants to work towards the back. A lot will have to go up and lap over to the back. This is more complicated because I needed it to be for my test. First off, when I lit it, I plugged up that door with insulation, mineral wool, because I needed to see how it would perform with the air coming in through that ash door. So I had to, for my test, I had to create two doors. There's a grate in the back and a grate in the front. Grate in the front, one brick wide, and the grate in the back, maybe two. You don't need to make a Firebox like this. You don't. I should have stressed this earlier. You just let me go back to that red brick, but it's still tiered in the same way. So the gases and flame they go over the top, and they also are drawn along the sides to the left and to the right. All you need, because again, this is fire brick here. You're putting a red brick box around this. You just need some kind of an alcove, literally, to toss wood into. That's it, and it will work. And it's going to be as good as almost any other masonry heater. So you don't need to. I might have misspoken earlier. You don't need to build doors or holes at all in this one, unless for some reason you think you want to. And I don't think there is any advantage. You just leave it open. And your red brick box around this needs to be more intricate, where your hole for the ash door, hole for the wood loading door. Guys, remember, if you're a novice, that simple version of what I just showed you with the mini bricks, it will work. Like the metal here, as the flames lap up, it will drive the flames to the left and to the right, so they go down the channels instead of everything going over the top. If everything goes over the top, only the top of your masonry heater will get hot, and the sides, the art of a masonry heater is all bricks get equally hot. So I probably would put something across so everything doesn't just go up across the top. If that metal kind of pushed everything left and right, you want the flame to come flying down the sides of your fire brick walls, between the fire brick wall and the red brick wall. The art is getting and there's your opening. That's a possible opening to have all your. You mimic the opening should mimic the size of the stovepipe and be a little bit larger. I draw that little V to make it a little bit easier for some of the gases to vent, and it doesn't have to be pointed backwards. That might make it a little bit harder to vent. You could have a hole on the left and a hole on the right. It just depends. The gases will stay in the stove a little bit longer if you have it facing backwards. It's just, it's up to you. It really doesn't make much difference, but you don't want to play it too close. Make sure that hole, up the pipe, is big enough. I think I'm talking here, but I cut my voice out. And you can, this, I'll just let this roll. But I made a little shelf, across the top, because I want the gases to be pushed forward to a degree. I don't want everything just to fly over the back and go down and out. They have a mind of their own. They know the quickest way out, and you have to really get the hot gases to touch all your bricks. Not all your fire bricks. All the fire bricks are going to heat up like crazy because it's the Firebox. Do you want it to equally touch all your red bricks? So one of the hardest things I did with my masonry heater is everything I felt wanted to go to the ceiling, to the top. So I made little sheet metal little ceilings, so to make the top less palatable or less easy for the gases, so everything would be pushed along the sides. That is without a doubt, unless you're you've been doing this for 20 some years like the Russians. The hardest thing is you make these stoves and it'll work, but you'll say, oh, this part's way hotter than this part. It doesn't heat up evenly. It'll still be a great heater if you don't get it perfect. That's what I recommend at the bottom with that V at top. To me, this design always looked like a knight's helmet. So I call it, the knight's helmet. You just, with snips, good quality snips will cut 6-inch stovepipe. This is galvanized pipe, but good quality snips. You don't get those cheapos, $7. Good quality snips that cut metal will be close to $20, and it's worth the money. You cut your stovepipe out and make sure the way the gases can enter your stovepipe to get out is a little bit larger than the 6-inch diameter of the stovepipe itself. This is the last video I'll show you before showing you some stills, and we'll go over the particulars like what mortar to use, etc. Guys, again, if you use sheet metal that's galvanized, it's poisonous until the zinc burns off. Do not breathe any of it. And make sure the wind's going in the other direction until it's all burned off. I do like putting something across like the sheet metal, because where I put my grates, I put one in the front, one in the back. It didn't do anything for me. Just put a good 15-inch grate in the middle. We have your air come up through the middle. Make sure it's air on the side of having a bigger grate. Air is key in this stove. Not a little grate. Just let all the smoke, let all the wood get the air. You're going to burn through a lot of wood quickly, but that's fine. That's the way these stoves work. You fire them up twice a day for an hour and a half every day, and they stay warm. I like the metal across the front. My flames were more towards the front. I couldn't get them to come up the back like I wanted to, although some come up the back. The balance was decent, but it was more front heavy, if you would. That sheet metal across the front drives the gases down the left and down the right instead of just over the top. You want to drive them to the left and to the right, so everything, all the red brick along the left and the right channels heat up evenly with the top. Don't want a stove where just the top 20 inches are piping hot and everything else is ice cold. The art is to make sure all bricks heat up evenly. Also, if I was building my red brick box over this Firebox, the red brick box really doesn't even need to be more than 3 or 4 inches above the top of the fire brick. Don't rest your red brick on the fire brick. You need to use lintels, angle irons, not lintels, angle irons to support your red brick. Can't rest it on the fire brick because they heat up differently and they expand differently. The fire brick, it moves around a lot as it gets piping hot. It'll crack your red brick. So don't just use that shelf there to help support everything. That is the biggest pain in the neck in this project. You need your angle irons. But I would also stuff a bunch of mineral wool across that top right shelf. Those bricks sticking up on the left, don't worry about them. You don't need them. I would stuff a bunch of mineral wool on the shelf the 2-brick shelf to the right. Stuff the 3 or 4 or 5 inches between the top of your fire brick and the red brick ceiling. The red brick ceiling should be 2 levels, not 1, just to be safe. It'll heat up just fine. 2 levels of brick. It's not safe because you could have a crack in the mortar, everything, then the gases will seep out, and it doesn't take that. The top gets hot, so both levels will heat up, and the more mass you have in the red brick, the more it'll hold heat for a longer period of time. Stove like this is not a gigantic Russian stove, but it's big. It'll hold heat for 6 to 8 hours, a good amount of heat for 6 to 8 hours after the fire goes out. So I played around with things like like stuffing the mineral wool between that shelf on the right, between the red brick and the shelf on the right, and even extending it a little bit. So I wanted my 90% of my gases to go down the sides. I didn't want them all going over the top and down. I guess I mentioned this, but if you're confused by this picture or confused by this scale, these are like little toy bricks, little mini bricks. And again, at the end of the day, this is really all you need to do. I would, on that, again, like I mentioned, that shelf, that 4-brick shelf at the top, I'd lay a bunch of mineral wool, stuff it in there, so my gases don't just run right over the top and down. That would not be good. But because it's tiered down, I mean, it has a mind of its own. It knows the quickest way to the pipe out, and because it's tiered down, I think it's pretty evenly. Some of it's going to flow over the top, some across the middle, and some, maybe pieces of your wood that are a little closer to the door are going to flow around the front and to the sides. The idea is make sure where they're clearing the sides to go down the channel between your fire brick and your red brick, make sure that's well above your door. But that's just, that's my pet peeve is I want to open the door when it's just raging. This is what, I can't do this with my ironwood stoves, and it's always drive me crazy. I had to wait until everything's just cold to add wood. With this, you shouldn't have to wait at all. If your door is, if you can build this up higher and can spend more money on fire brick, you can go higher, no doubt. The more the flames can lap up high, the more smoke is going to be eaten up. If it's going around the corners in the front, well above your door, then you can open that. You'll be able to open that door up, throw wood in anytime. You get no smoke. You don't want the door at the level of the first level of the first tier, because it's going to want smokes and gas are going to want to come forward because it knows the quickest way out, and there would be a risk. I should have stressed that. Make sure this is where the tiers start, are well above your door. If you want to be able to add wood at any time, even when the fire is completely raging. This is my stove under construction. The top isn't done. Of course, you can see the firebox there poking up through the red brick. You can see that I only have 3.5 inches on the right and on the left. Not recommended to be that tight. It works, but you want more like 4 or 5 inches. There's no reason to be that tight or to play it that close. Because I played it so close, I allowed a little more room for the gases to go over the top if they needed to. So that little door up top, guys, that's just for fun, just a little viewing door to look in. You don't need that. It's not a clean out door. There's nothing to clean out there. Remember our firebox, my firebox is more like that little mini red brick. There's nothing to clean out there at that moment, just a viewing door. The door below it is the wood loading door. It's pretty small, but you can get, good sized pieces in there one at a time. But the point of me showing you this is, remember on the mini bricks, those tiers go down, and you want those tiers to the gases to start escaping about 3 rows up from your door if you have the room to go that high. That way there's no chance the gases are gonna want to come flying towards your door and use your door as a way out when you open it. Kind of like I just mentioned in the last segment, but that can't be stressed enough. If it's all at the same level, you open that door, everything's going to start pouring out your door. So let me show you this just one last time. It's not to scale. I just did this quickly, and some might say there's no grate here. Yeah, there's no grate, and this is just a sample firebox, so you could see. Once you do those 3 levels of like the horseshoe, then the next level you do a half, and it all fits together nicely. You need very few half cuts. You just keep going. As you stagger, you'll go one less, and it's a half less. You'll see it all fits together. There's very few cuts, half cuts. Let me bring the last image up, and I'll go over all the real little nitty-gritty details as quickly as I can for anybody that wants to build this stove. Let me use this program now where you can see the cursor. I like this firebox a little bit better than just what I did with the mini red bricks, the real simple firebox. This is a little bit better, but I just want to tell you a few things. This should all be open, guys. Remember, I needed to do this for my test. I needed to plug this hole and pretend it was a door with insulation. And this should all be open. Now this can't be open. You need to build a grate in here. You need to have a grate along the middle 14, 15, or 16 inches of your firebox needs to be a grate. We'll talk about that a little bit later. So you will need you do need, of course, fire bricks going across at this 3rd level, and of course the base level. And then this is open for your ash pit. Your ash drops down here. Also, I probably only used 1 brick for my ash pit because it's just a test. You'd want to make sure you have enough room to get your shovel in there, of course, and ash piles up. You want to make this a little bit higher. But all this up here is wide open because you want the flames to heat up your red brick, the red brick that's holding the door. So again, just don't be confused by my test. It was convenient because I like this shelf here. I do like this shelf. Sheet metal, whatever. You put a piece of soapstone, and you could put anything in there. But you couldn't put concrete or if you pour a little square, because it's going to be blasted with flame. it has to hold up. It either be metal or soapstone. I like this because here again, you see it's not a great angle, but you can see the hole via this tiered system. I have this hole on the right, and there's of course a mirror image on the other side, where the flames blast against this sheet metal, and they pour out this hole and they pour out that hole. In the real stove, where there's a pipe drawing from the bottom, your flames are going to go they're going to go along this channel here. Again, there's going to be just 4 to 5 inches between this wall and the wall of your red brick. So they'll be pulled down and across the red brick, and then on the other side as well. So without this like little mini roof, I'm afraid the flames are all going to shoot up to the top and find their way around the back and down the bottom, which means 40% of your stove is not going to heat up real high. I really think this is important, but it's not that important, not completely necessary. If you just have that what I showed you with the mini bricks, the completely open firebox, you just load it up with like 5 pieces of oak, it's going to get so hot, everything's going to heat up. It's really not going to matter. Again, these bricks sticking up here, you don't need these. Anytime you can add mass, though, add mass. They're just to hold the piece of sheet metal. But remember, guys, out the back, they have another, at the very top here, have that other hole with the 4-brick shelf over it. And I was trying to get, with where I placed my 2 grates, I was trying to get equal. Most of the flames wanted to shoot up towards the front. Most of the flames you saw from the video slammed against the top of the sheet metal. And in the real stove, they'd be drawn down left and right. Not as much flame and gases came out the back. But, that's okay. You would want it up front. If everything came out the back, it's going to find a way around the sides and go down the back. Your front of your stove would be cold. So, I like if you build it, it's all open except this box at the bottom, which you need a fire brick. You need this. You need a shelf to hold the grate. You need a shelf to hold, 30, 40, 50 pounds of wood. So but all this here between the 2 sides is all open. And if your sheet metal was thicker, again, it could be all open. You don't need to make a little door. You make this little door in the red brick, and I don't know. I mean, just I guess I've given you as much. You're gonna have to at some point make your own decision, giving you as much information as you need there. So, is there anything else I want to do with the cursor? No. I guess I'll just show you the final image, and we'll go over the mortar and all the really fine details. Okay, guys. Last image. I found a picture of my firebox in my stove, but it's not quite done. You can see the red bricks box is being built around the firebox. The firebox is almost done. The red brick box is just starting. That little alcove in the back on the right is for the pipe. That's the little alcove I put the chimney in, with the big hole cut at the bottom of the chimney. This firebox isn't done. You load the wood from the left side. The gases and flame come flying up through this square. You don't need your square to be this big. I just aired on this side, but I'm glad I did. A lot of the Russians just use a 1-brick opening, but I think that's a little tight. But then I put another fire brick square tunnel on top of this to force the gases out towards what would be considered the left. And then they have to wind around the sides, of which I'm again a little tight there, just 3.5 inches, even under 4 inches on each side. It worked, but it's a little bit tight. Okay, everything you need to know. For the firebox, here I built my firebox first, and then I built my red brick box around it. That's just what I preferred to do, and there's no right way, no wrong way. Use refractory mortar. It's expensive. It's like $45 for a 40-pound bag, but you probably only need 1 bag. Your joints for fire bricks should be very, very thin, almost like there's no joint. If you butter it on sloppily and you have an extra bag, and hammer it down with a rubber hammer so it squirts out the side, your joint should be almost like nothing. If you're not a good bricklayer, but keep a little joint sometimes, because you need joints to make up for mistakes from time to time. So wet your bricks. Soak fire brick underwater in a bucket for 30 seconds to a minute. Not one quick dunk. No, these absorb a tremendous amount of water, and it will take your water out of your refractory mortar. Not just a little dunk. Definitely not spray, spray, spray. No, you got to put it in and leave it in as long as you can stand it, 10, 15, 20, 30 seconds, and then butter it or whatever. I found that it's better to do these one at a time. They absorb so much water. I try to do whole rows at a time, and when I get to the end, it's like drying up already. Because I didn't dunk them for that long. It's really important. The joints, I learned the hard way. My joints in this Firebox were too wide. I'll get away with it, but you almost do it like a 1/16 of an inch. Okay, enough said on that. All right, so for the red brick, I used pavers because I like the pavers are symmetrical like fire brick. 2 up is the same as 1 over. Regular red brick is not symmetrical. 2 up is not the same as 1 over. Regular red brick creates a lot more cuts. If you have a wet saw, you can cut brick easily, no problem. If not, you might want to use pavers because it's all symmetrical, all fits together nicely. Pavers are typically clay and shale, just like red brick. It doesn't matter really what type of red brick or pavers you use. These bricks are fired to 1,800 degrees, 1,900. They can stand the heat. They're not in the ridiculous heat of the Firebox. It's hot. What's flowing around the corner is 700-800 degrees, but it's not the Firebox. You need the refractory brick for the Firebox. Just any old red brick. Again, be prepared with a wet saw to make a ton of cuts if you don't use pavers that are symmetrical. Okay, what mortar for the red brick? My choice is, the traditional is 3 parts sand to 1 part. Don't use play sand. Use the Quikrete builder sand or masonry sand. 3 parts sand to 1 part clay, fire clay. Fire clay now is like expensive, $30 to $40 a bag. I chose also to add 1 part of lime to my mix for my red brick. 3 parts sand, 1 part fire clay, 1 part lime, and it's just a sprinkle of type S or type N cement, which is dirt cheap at Lowe's or Home Depot. It just allows you to work more quickly. It sets up quickly. It gets sticky in 5 or 10 minutes where you can keep working. If you just do 3 parts sand and 1 part clay, there's no glue in there. It'll set up and hold if everything's perfectly symmetrical and level. But it's hard to keep, unless you're an expert, it's hard to keep working. Because I'm talking about the red brick now. Again, remember, it's refractory mortar for your fire brick. I'm talking about the red brick box around the fire brick box. If you just use 3 parts sand and 1 part clay, especially if you have bricks that aren't absorbent, it kind of slides around. Sometimes it takes weeks to really dry out. I don't like that. The temperatures are not extreme where you're not going to have a problem adding 1 part, even the crap hydrated lime, which is sold at Lowe's and Home Depot in the U.S., and not just a little sprinkle on top of that of type N or type S cement. It's just a small amount. It's not going to break down in the high heat because your base is still 3 parts sand to 1 part fire clay. I preferred to butter 1 brick at a time. I'm no bricklayer. 1 at a time, and it took me forever. And with my level, torpedo level, check it front ways, check it sideways. Tap the back, tap the front. Check it check one way, check. Again, smaller joints is better. But if you're going to make mistakes, having a little bit larger joint, whatever the standard is, 3/8 inch for a red brick, allows you to make up for mistakes on your level if you screw up. So it's okay to have a bigger joint. Hardly any joint for the fire brick. A decent little joint for the red brick. I needed it to make up for mistakes. My joints are too big. It looks cool, but it was a lot of work and a lot of buttering. I had buttered them 1 at a time, and then it was tap, 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 level, check it. Tap, 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 check the level. Whenever I tried to do a whole row at once, it just never worked out. It just would start to dry up when I got to the end, and you do have to at least spray your red bricks down. You dunk whatever bricks you use, throw it into a bucket to start, just to test. If it bubbles like crazy, it means it's porous. It'll absorb a ton of moisture out of your mortar. Some bricks are very smooth, and you throw them in water and nothing happens. Then you don't need it. You just need a very light mist. You don't need a lot of water or dunking. If your brick bubbles like crazy underwater, it's going to pull all the water out of your mortar unless you spray it the crap out of it with spray bottle or dunk it in water before you do your mortar. Some people like just use rubber gloves. They'll just, they'll put their tarp on the ground, make an absolute mess, but just do it with rubber gloves. And again, remember your porous brick where you throw it in the bucket and it bubbles. If your mistakes if you use lime, it wants to make everything a little white. I thought the look was cool. You saw mine. It has these white lime stains, and I thought it was cool. It looks old, but if your brick is porous and you make mistakes, it's hard to clean it up unless you get on it right away afterwards. So these are, I'm not, I guess, no reason to talk about aesthetics. I just stick to in this my Firebox. You see a little Russian dry slit. It's a little slit at the bottom. You don't need it. You don't need it. But you know what we do need to talk about? Priming and drafting initially. Do need to talk. That's very important. Let me maybe I'll end with that. I'm sure I forgot something else too, but let me end with how do you prime it? How do you get it started? Oh, one other thing from an aesthetic standpoint, the top right, you see my bricks that I've piled up there that I'm getting ready to use. You see how they're black and stuff? The aesthetics were really cool. I use those bricks in so many tests, like in my garage or whatever, stove tests, or just hundreds and hundreds of stove tests because I'm some sort of a nut, that they all got black from all the tests, and it just, I don't know, the look was pretty darn cool. If you wanted to do that, you just basically build a giant rectangle square of red bricks, and just you want to keep the oxygen very low and just smoke the crap out of them, and you'll get black stains all over everything. I think it looks pretty cool. I know I need to talk about how to start it and prime it. It's extremely important, but I did find one other picture showing you the completed Firebox inside the red brick box with that final tunnel where the gases come up that hole, that square hole in the back, and then through that are forced towards you, and then they'll lap around to the right and to the left. And you can see how just is that thin little area, 3.5 inches or so. I'd go 4.5 or more. Don't make it too wide though, because everything will slow down. But this was enough. In terms of percentage of the stove being Firebox to red brick box, this probably takes the cake or breaks the records. The percentage, the Firebox takes up takes up 95% of the room inside the red brick. That's unheard of, but it works, and I like it. All right, this is a good final image to show you so you can see how everything is done. The bottom, I have bricks plugging up that ash door, or that's the air door. You can see the air. My grate, I just made the whole thing the grate. I mean, why mess with the air? Just allow as much air as possible, which the efficiency goes down and it burns through the wood very quickly, but there's no smoke. I put bricks through in that door. That's a big hole at the bottom. That's square. Forget those bricks just come right out. I don't even know why they're there. But when you build your Firebox, just leave it open like this. Leave it open. Once you have your of course that part that holds the grate there, I just used pieces of metal, iron, all different pieces of scrap metal. I left a lot of air to be able to flow through. Don't make your grate where it's so thin and trying to hold the coals. Just let the air flow. I mean, don't err on the side of letting air just go all over the place. Once you build that, then going all the way up, it's just completely wide open. So all those flames can equally warm up the front of your brick box in addition to the sides and the back. Okay, most importantly, here we go. I promise this time. Priming, getting it started. If you spend all this time, money, and effort, thousands of pounds, it doesn't draft properly, you can't get the draft moving in the right direction, it's worth nothing, or you don't want to smoke your house out. Got to heat everything up first so everything moves in the right direction. So let's talk about the ways to do that. Bypass damper really doesn't work in this stove with one exception. Remember, your pipe, you're looking at the back of the Firebox. The entrance to the chimney or the entrance to the pipe is behind the Firebox there at the bottom. So where are you going to put the bypass damper? I guess there's a company called firespeaking.com, I think it is, Firespeaking. They have the bypass dampers with the long handles. I guess you could find a way, if you really knew what you're doing, to put a bypass damper into the back of the Firebox, but I don't. There's other ways to do it. That's a mess. You really would need to know what you're doing because it's a thin firebox. So forget that. This doesn't work for bypass dampers. So what do you do? All right. The easiest way you're going to need, if you're going to use this for 20 years in your house, you need clean outdoors. And the clean outdoors, your little 6-inch clean outdoors would be the back, from the way we're looking at this picture, back left in the brick box, back right in the brick box. Depending on how far your brick box goes back or your orientation, you want to be able to get in and clean those channels, that thin channel between the fire brick wall on the left and the red brick wall on the left and the fire brick wall on the right, the red brick wall. You need to be able to get in at some point and clean that out. Clean out the area around the entrance to your pipe, which is along the bottom of the stove, so ash and stuff can build up. However, if you have the two clean outdoors, one on each side, maybe I put one on the side and on the other side I put one along the back. I don't know. What did you do, Matt? Because this was just a big gigantic test. I did put in bricks with no mortar. I used just clay and sand. I don't have clean outdoors because I don't have a chimney yet. So but I know it works. Put it that way. Let me just leave it at that. If I started using it all the time, or I got a full chimney, then those bricks that I put in with no mortar, I would just punch them out and put in clean outdoors. Anyway, you open the clean out door in the back, and it should be right there at the base of your pipe. Your chimney along at the bottom that takes in the gases along the bottom is right there. You'd have to light a little fire in the back of the stove that would go right up the chimney, start heating up the chimney. And, after 5 minutes or so, then you just light everything normally from the front and it would draft. And then he was like, I'm not going to do that. I need to get in to the back of the stove and light a little fire in front of the chimney and warm the chimney up. I got to light a little fire through the clean out door every time. Well, look, these stoves they're not meant to be burned when you're bringing the girlfriend over with a bottle of wine just on a Friday night. They're meant to be burned at least once a day, if not twice a day, for 6 to 8 weeks straight through the cold snap of New Hampshire or whatever, to get you through the cold snap of whatever your winter months are. Once you prime it once in the back, you open your little clean out door, build a little fire, and have the flames go right up that pipe. Warm the pipe. You have to do only just 5 minutes or so. It'll warm up. And then everything will draft normally. Once you do it once, you're not supposed to just let it go then and come back 3 weeks later and everything's ice cold. If you burn it at least once a day, it should stay warm enough. Unless your pipe is, 20 feet of the pipe is outside in 0-degree weather. That can be a reverse flow type issue. You got to be real careful with that. But I can't turn this into a giant chimney conversation. You're only basically going to have to prime it once. So it's not a big deal to build a little fire with paper and newspaper in the clean outdoor one time every 6 weeks if you fire it every day. So that's primarily what most people would have to do with a stove like this. I built my Firebox on top of the red brick box, and you can actually get a shovel underneath all the fire brick. If you were to pull out that square there at the bottom, you pull out those 2 bricks, you can see all the way down to the pipe. You can see all the way down in the pipe. So my idea was you'd put there's some real good fire starters. It's like a big chemical in a little baggy type thing or a plastic thing. Ignitos, they're called Ignitos, not the square pieces of resin. If you take an Ignito and you slide it all the way down into the pipe, that can prime your chimney. So I have a way through the front there, that bottom square, to get all the way back into the pipe for priming, which hopefully, again, I would only need to do once. So that's another thing that I did, but I jacked my fire brick up, which was pretty easy to do using the size of the pavers that I used. But anyway, so that's another way of doing it. A damper along the back of the Firebox. You can get these dampers from with the long handles from firespeaking.com, but that's awfully difficult to do. It is possible, though, a damper towards the back of the Firebox that, with the handle, opens and swings open just by turning a handle. That would be long enough, hopefully, to come out the side of the red brick. What I did is I have there's these little tiny mini wood stoves, cheap, old. just with the vents out the top. The cheapest, they're like from US Stove Company, whatever. Rip the legs off and put it on two cinder blocks and then connected the pipes together. So, in other words, start a fire off to the side in a little mini wood stove. So the entire chimney system is heated up. Let that fire go out, then light this fire. It's not the end of the world. Your pipe, your 6-inch or 7-inch stove pipe is going to be situated behind the back of this firebox. It's going to go straight up 4 or 5 feet to get out of your through the ceiling of the red brick. And then at that point, there's all sorts of T connectors, and I have pictures of it. You just use a T connector, and your pipe continues, but you use a T connector that goes off to the left or to the right, and you connect another stovepipe up from another little mini stove or some cheap thing. And that having another stove off to the side isn't really workable for most people. I hear you. All right, is there any other way to do it? There's a lot of different ways for me because I can slide the thing across the bottom. What am I missing? There's got to be something else. Well, there is something else. You could. It depends on it depends on how you put your chimney or your pipe in the back. You can have a T at the bottom of your stove. So that T would need to come out through the red brick towards the back at just say 6 inches or 8 inches above the entrance to the pipe. So you would open the pipe would come out through the back of the red brick. You'd have a cap on it. You'd open it up, hopefully just once every 6 weeks. You'd burn a little fire inside your chimney that way. You need access to clean out the pipe anyway, but if you have those clean out doors in the back, and you have you use your chimney sweep tool to sweep your chimney every year or so, and everything falls down the pipe into the stove, that's fine. It can fall down, and all the ash can collect at the bottom of the stove. If you have your two clean out doors behind the firebox, you can open those clean out doors, scoop ash out, shop vac, or with the HEPA filter or whatever around your pipe, get everything clean once a year. So the other way, of course, if you have your T, you're going to need to clean out door anyway. So it's kind of to have the T that goes out the back of the red brick. It's for chimney sweeping and to prime is kind of redundant because you're not going to be able to clean your stove with that T. It's just redundant. Again, I like the best way is the easiest way, I guess, is just the little clean out doors, back left, back right, and you almost would need three. It's tough to you need one along the same orientation as the channel, so you can get your little shovel or your shop vac into the channel once every few years to clean it out. It's going to be okay. Ash could build up for years, could build up 4, 5, 6, 7 inches. It's still not going to block the efficiency of the stove, but you don't want it to build up more than that. So you need to be able to see down along the channel between the wall of the stovepipe, between the wall of the fire brick and the wall of the red brick. Need to get into that channel. So the clean out door would need to be straight at the back along the same orientation. And then that might be the best, two clean out doors along the back. But it would make it hard then to clean out if you needed to sweep the chimney and all this ash dumped down to the bottom of it, the back of it. It would be hard to clean that. So you almost need another clean out door. It's not that it seems like a pain in the ass, guys. Some of the Russian stoves have 6. I've seen them with 6 to 8 clean out doors, the big ones, with many channels going up, down, left, right. If you can't clean it, it's worthless. You just put a little 6. It's easy. It's a little 6-inch door, a little square, mortared in, with some mostly sand and clay, not cement. So you can, if you have a problem, you can chip it out and put it back in, and little door opens up, and again, I'm talking about putting 3 in here, and your major Russian stoves I've seen with 6 to 8, and so that's a lot more. But anyway, so I know it's been all over the place. I got to wrap this up, of course. Gotta find a way. Don't say you got to find a way to heat that pipe And if your chimney, if your pipe goes out the wall and then up 20 feet in the ice cold, you need a real good way to heat that pipe, or it'll go backwards on you and you'll smoke your whole house out. If your pipe goes straight up through the warm house, straight up through the relatively warm chimney, only a small part is exposed to the ice cold, then you don't have to do as much. Don't have to be as perfect with your priming. If you have a pipe that goes outside into 0 degrees and goes then 15 feet in the ice cold, you better find a way to heat it up, or you're gonna have a reverse flow issue. Thanks for listening.